Question 7, the equation of a circle is this one here. The line with this equation here is a tangent to the circle. Find the two possible values of A. Now we are going to solve these ones simultaneously, and then we use the condition for tangency. Okay, so for intersection, I'm going to use substitution. Okay, I'm going to substitute it. So this whole thing here, I will put it where y is. Okay, so we shall have x minus 6 squared, then plus, this will be 2a minus x, then there is an a, then squared, this one is equal to 18. So still we have x minus 6 squared plus 2a plus a, that is a 3a. So 3a minus x, then squared here is equal to 18. Now we can open up the brackets. This will be x squared minus 2 times x times 6, that will be minus 12. So minus 12 of x, and then square the 6, that will give us 36. Then we come to this one here. When we square, that will be 9a squared. And then 2 times 3a times the x, that will be minus 6a of x. And then you square the x, that will be x squared. Then I can bring this 18 this side such that it becomes a minus here. I want a quadratic equation that comes from here. Now x squared plus x squared, that one will give us 2x squared. And then the ones that have gotten x, we have the negative 12 here, and then minus 6a. So negative 12 minus 6a, that one is of x. And then the constant term we are having here is 36 minus 18, that is 18, okay? And then plus 9a squared. So 18 plus 9a squared is equal to 0. For tangency, because that is one point of intersection. Remember, when we are solving the quadratic equation, we are supposed to use the quadratic formula. So x is equal to minus b, then plus or minus the root of b squared minus 4ac out of 2a. Now, this discriminant here in the square root, it is the one that determines the nature of the roots. So if it is equal to 0, that means this whole thing here disappears, right? That means you're going to get one repeated root, which is actually minus b out of 2a. So if we are having a curve and then the line meets it at 2 points, then this one has to be greater than 0, such that you can use the plus or the minus, right? But then if it meets it at only 1 point, like this, that means we are going to have a repeated root. That means the b squared minus 4ac has to be equal to 0. So therefore, for tangency, b squared minus 4ac is equal to what? 0. Now, what is our b? Is negative 12 minus 6 of a. We square it, then minus 4. Our a is a 2, and then our c is the whole of 18 plus 9a squared. Like that. Then we equate it to 0. So when you square this 12 here, it will give us 144. And then 2 times negative 12 times negative 6. Of course, that is like 12 times 12, so that will be 144. So positive 144 of a. And then when you square this one here, it will give us 36 of a squared. And then this one here is 8 times 18. 8 times 18, that is 144. So negative 144. And then this one is 8 times 9, which is 72. So plus 7, actually it is a minus, sorry, minus 72a squared, which is equal to 0. Now, 36 minus 72. Actually, I'm going to take everything this other side, right? So that the coefficient of a squared is a positive. So 36 minus 72, that is minus 32. So when I take it to this other side, then I will get positive 36 of a squared, okay? Then next, I will have 144a. That one, when I make it go this other side, it will be a negative, okay? So we shall have minus 144 of a, which is equal to 0. Automatically, we can see that this one disappears, okay? Now that is what we are having there. Now 36 goes into 144. Those are 4 times. So if I pull out 36 of A, and then here I have, what do we have inside here? A, then minus 4, which is equal to 0. That means when I get this one and I equate to 0, A becomes a 4. And also when I equate this one to 0, A becomes a 4. So that is that. We shall take A. Actually, A has these 2 values because they said for 2 possible values of A. Okay, so that is 0 and 4. Part B, for the greater value of A, that is A is equal to 4, find the equation of the diameter which is perpendicular to the given tangent. Now, we are going to have our circle here. Just doing a small sketch. Then here we are having the center. Let's go back. When we check here, the center is going to be this 6 here, and then the negative A from here. Okay, the negative A. And our A is 4, so we shall have negative 4 here. 6, then negative 4. Okay. Now, from the sketch here, we can see that the equation of the tangent is this one. It is actually the same as saying y is equal to negative x. Since A is 4, then plus 8. That means it is slanting like this because the gradient is a negative. Okay. So when I go back to our diagram here, I can have maybe that line, the tangent. Let me just put it, let's say here, like that. It has that equation y is equal to negative x plus what? 8. So I don't know where it meets with this one here. But we know that in circle theorems, the gradient, I mean the tangent and the radius or the diameter are perpendicular. Okay, so m1, that is the gradient of the tangent, is negative 1. So meaning m2, which is the gradient, okay, gradient of the radius or diameter, gradient of diameter, then shall be equivalent to negative 1 over this negative 1, which is equal to what? 1. Because you know we are using m1 times m2 is equal to negative 1 for perpendicular lines. All right. Now from there, this equation here, let me write for you something here. A tangent is always perpendicular. A tangent is always perpendicular to the radius or diameter. So we have y minus y1, which is equal to m into x minus x1. That is the general equation of a straight line. This straight line, the diameter passes through the center of this circle here, which is 6, negative 4. That means we can have y, then minus 4. So that will be a plus 4. Then it's equal to m, which is 1. And then x here minus 6 here. When I open the brackets, we shall have here x minus 6. Then when this one crosses, it's a minus. So it will be minus 4. And therefore, the equation of the diameter is going to be y, which is equal to x minus 10. As simple as that.